So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So, machine voices, human mind.
Carry on. Welcome to Plain Strata, where we take decentralized AI apart one layer at a time. This is Pulse 3, and today we are talking about the two rival protocols that just gave AI agents a real way to pay for things on their own, and why the world's biggest payment networks are betting on both.
The physical reality of this is already happening. I mean, literally this week. One piece of software rented a few minutes of a paid browser session, ran its errand, and let the session expire.
Just completely on its own.
Right, completely on its own. And somewhere else, another piece of software paid to have a letter printed on real paper and mailed to a real physical address. Another one paid for a sandwich.
Okay, a sandwich. I love that.
It is wild, but the crucial detail for you listening right now is that no human clicked approve on any of it. There was no person watching a screen. It was just software deciding it needed something, finding the price, and paying for it.
That was the why. The how is the rest of the show, and no background is needed. If you can follow a story, you can follow this.
The core argument we are unpacking today is that software has never been able to pay for things by itself. The entire financial system requires a human being.
Right, because of fraud protection and identity checks.
Exactly. But this year, that limitation changed twice, independently, and both times they used the exact same 29-year-old unused piece of the internet.
Which is such a fascinating detail.
It really is. And that shared origin is exactly why the companies that move the world's money are now hedging their bets on both of these new systems at once.
So to understand why this shift is so massive, we first need to define what we mean when we say an agent, because, that word gets thrown around a lot right now.
It does. In the context of this show, an agent is not just a chatbot answering questions. An agent is a piece of software that can decide something and act on it without a person approving each individual step.
Like it has its own autonomy.
Yes. But until this year, the moment an agent needed to actually buy anything, real commerce simply stopped. A human had to step back into the loop.
Somebody had to come in and type out the numbers.
Right, to enter a card number or click a button to approve a charge or accept a recurring subscription. That requirement is the single choke point the tech industry has been trying to solve.
Which makes sense when you think about how our current payment rails are built. I am trying to picture the exact moment a machine hits a wall. Let's say my AI agent decides it needs more storage space.
Okay, let's play that out.
It navigates to a cloud provider's website. It clicks buy. What happens next?
The cloud provider's checkout page asks for a credit card number, an expiration date, and a security code. Let's assume the developer gave the agent a corporate card to use. The agent types those numbers in.
Okay, so it has the payment info.
It does, but then the checkout page asks the agent to click a box, proving it is not a robot.
Right. The CAPI-TCHA, the literal test designed to stop automated software from proceeding.
And even if the agent uses computer vision to solve the CAPI-TCHA, the bank processing the credit card is running its own behavioral analytics in the background.
Wait, the bank is watching how the form is filled out?
The bank measures the time between keystrokes. It measures the geographic location of the IP address. It measures the velocity of the transaction.
So using a traditional credit card for an AI is essentially like handing a teenager your wallet. The bank just assumes it is a mistake because the spending patterns are completely unpredictable and chaotic.
Let me correct that analogy slightly. It is more like handing a supercomputer your wallet. An AI agent does not act like a chaotic teenager. It acts like a hyper-efficient machine.
Oh, I see. It is too perfect.
Yes, it can execute thousands of transactions a second. It does not pause to read the terms of service. To a traditional bank, that sheer speed looks exactly like a brute force hacking attempt.
Wow. So the bank sees a script running massive numbers of microtransactions and shuts the whole thing down.
Because it operates at machine speed, the security tripwires are instantly triggered. You cannot teach an AI to browse slowly just to fool a bank's fraud algorithm.
The physical reality of the problem is that every single existing payment rail relies on human verification. You need a name that a bank can call on the phone.
You need a physical signature that a court of law can enforce. Or you need biometric data, like a face scan on your phone, to authorize a digital wallet.
Which is why the source material says developers had to create a completely new kind of yes, a verification mechanism that banks do not have to trust as a human person at all.
They just have to trust the math.
But I am not sure yet. Let me think. What is the actual math here? We cannot just say cryptography and move on.
Think about how you unlock your front door. You use a physical key. In the digital world, an agent holds a private cryptographic key.
Which is just code, right?
It is essentially just a massive, unique string of letters and numbers hidden deep inside its code. When the agent agrees to a price, it uses that private key to mathematically sign a transaction.
Okay, so the receiving server looks at the mathematical signature, verifies it matches the public record of funds, and approves the sale.
Exactly. No passwords, no text message verification codes, no human identity required. The machine talks directly to the machine.
By shifting the mechanism from human trust to cryptographic proof, the entire bottleneck disappears. The payment goes through instantly.
But the machines still need a place to talk to each other and exchange these signatures. To create this space, developers did not start from scratch.
They went digging into the archives.
They did. They found a solution sitting completely empty in the original rulebook of the internet. Every time your web browser talks to a website, the website replies with a 3-digit status code.
And those codes mean something very specific. The rulebook governing this communication is called H-TP, spelled out phonetically, that is Hypertext Transfer Protocol.
The important part here is how that protocol handles connection state. If you request a page and everything works, the server sends back the number 200.
Which just means here's your page.
And if you click a broken link, you get the famous 404 code, which tells your browser nothing is here.
We all know that one.
But back in the mid-90s, when the web's earliest designers were writing the official rules for HTTP, they set aside another number. They reserved the code 402 and they labeled it payment required.
Wait, so every web browser has had a built-in checkout counter since the 90s, but nobody actually built the cash register.
For 29 years, 402 sat in the rulebook completely unused. It is widely considered the most famous feature the web never actually shipped.
That is wild.
Every browser, from the earliest versions of Netscape to modern Chrome, has known about this status code since 1997. The original vision was that someday, paying for a piece of information online would be just as automatic as loading a web page.
So an agent would hit a paywall, receive a 402 code, automatically pay the fee, and get the content.
That was the dream.
Why did it take almost 3 decades to build the cash register? If the room was already built into the internet, why was it completely empty? Let me take a guess. Was it just a lack of consumer demand for micropayments?
Consumer demand was part of it, yes, but the real issue was the physical architecture of the web. The internet is fundamentally stateless.
Meaning it does not remember you.
Exactly. When you load a website, the server forgets who you are the moment the page finishes loading. To make 402 work automatically, you need a persistent digital wallet that travels with you from site to site.
Ready to move money without you typing in a card number every single time.
And in 1997, nobody could agree on how that money should move securely across a stateless network without a massive central bank sitting in the middle of every transaction.
Without a decentralized ledger or cryptographic wallets, sending credit card numbers automatically in the background was a massive security risk.
So the empty room sat there gathering dust, waiting for the technology to catch up.
Which brings us right to our central premise. Because in early 2026, 2 rival coalitions looked at that exact same empty room in the rulebook and decided to finally build a cash register.
Using modern cryptographic wallets. The first of these 2 rival protocols is called Buy402. It was originally built by the cryptocurrency exchange Coinbase.
Okay, Coinbase.
Then on April 2, 2026, Coinbase moved the protocol into a new nonprofit organization called the Buy402 Foundation. This foundation is run jointly with the Linux Foundation,
Which is the exact same organization that stewards the open source Linux operating system. And wait, the April 2 launch date, 402, is a very intentional joke, pointed directly at the HTTP status code itself.
It is.
I love that kind of nerd humor. But how does Buy402 actually function if you are an AI?
The mechanism behind Buy402 is designed for one-shot transactions. Let's go back to our physical scenario. An AI agent wants to buy a data set. It sends a request to the server.
And the server says no.
The server blocks the request and replies with the 402 code, but it attaches a cryptographic invoice with a specific price. The agent reads the invoice, checks its available funds, and pays it instantly using a stablecoin.
Just to lock in the terms for you listening, a stablecoin is simply a digital token that is pegged directly to the value of the US dollar.
It moves instantly on a blockchain, but it holds a stable, real-world value so businesses can actually account for it without worrying about wild price swings.
Under Buy 402, it is one request, one immediate payment, and the transaction is done. The server verifies the stablecoin transfer and instantly releases the dataset to the agent.
And the scale of this became massive very quickly. By the summer of 2026, the CEO of Coinbase stated that the network had processed more than 160 million of these machine-to-machine payments since the launch.
Massive scale, but mostly driven by microtransactions, right? Fractions of a cent to read an article or a few dollars to rent a graphic processing unit for 10 seconds.
That volume is exactly what Buy 402 was built to handle.
But Buy 402 is not alone in that empty room. There is a second team that walked through the exact same door.
The rival protocol is called the Machine Payments Protocol, or MPP. This one was built by the payment processing giant Stripe, working together with the investment firm Paradigm, and Paradigm's own payments-focused blockchain called Tempo.
And they launched pretty close to the other one.
MPP went live on the Tempo mainnet on March 18th, 2026.
That was actually over 2 weeks before Buy 402 launched its formal foundation. And MPP answers that same 402 status code, but the underlying mechanism inside the protocol is completely different.
Instead of making one individual payment per request, MPP is session-based. It opens a running tab that an AI agent can draw against over a period of time.
Oh, interesting.
Then it settles that tab using whatever funds the agent happens to have on hand. That could be a stablecoin, it could be a traditional credit card, or it could even be the Lightning Network.
I need to pause on the Lightning Network for a second because we promised you we would explain how things work. You cannot just name a network and keep moving. How does Lightning fit into this machine payment ecosystem?
The Lightning Network is a secondary layer built on top of the Bitcoin blockchain. If you broadcast every single tiny payment to the main Bitcoin network, you have to wait 10 minutes for confirmation.
And pay a massive transaction fee.
That does not work for an AI trying to pay fractions of a cent. So instead, two machines open a private channel between them.
Let me guess. The channel acts like a temporary ledger.
The channel acts exactly like a temporary ledger. They lock a small amount of funds into a smart contract. Once the channel is open, they can pass thousands of microtransactions back and forth instantly for almost zero cost.
Because it is all happening off the main chain.
Right. The main network does not see any of this activity. The machines only broadcast the final tallied balance to the main network when they close the channel.
Okay, so if I'm looking at these two systems side by side, Buy 402 is a vending machine where you drop in a single coin for one specific item. But MPP is opening a tab at a bar to order the sandwich and rent the browser session and maybe order a few more things before you finally close out.
Renting a browser session by the minute is the perfect example. It is an ongoing, unpredictable session. The agent does not know exactly how many minutes it will take to scrape the data it needs.
So buying it 1 minute at a time would be a nightmare.
Exactly. Opening a running tab allows the agent to just work and settle the final bill when the job is done. That flexibility is why MPP was reportedly wired into more than 50 services within its first week of launch, including OpenAI, Anthropic, and Google's Gemini.
Both of these protocols give AI agents the practical power to spend money, which brings us directly back to the spine of our story. This new ability is exactly why the massive payment giants are suddenly so interested.
But here is where the corporate alliances get genuinely complicated.
Yeah, let's get into that. Stripe built the Machine Payments Protocol. But Stripe is also a founding member of the rival Buy 402 Foundation.
And Visa and Mastercard are founding members of the Buy 402 Foundation as well. But Visa has explicitly confirmed that they are supporting both rails.
Wait, so the same handful of companies building Buy 402 are simultaneously building or plugging into its direct competitor. Nobody is picking a single winner.
The biggest financial networks on Earth are playing both sides of the board.
I am guessing they are doing this because they understand structural engineering better than anyone else.
They understand a structural pattern that engineers call the hourglass model. The entire internet is shaped like a physical hourglass. At the very top, you have a massive, constantly changing variety of applications.
You have websites, email clients, streaming video games, and AI agents.
And at the very bottom of the hourglass, you have a massive variety of physical infrastructure. You have fiber optic cables running under the ocean, satellite links in orbit, the physical servers sitting in massive data centers, and the Wi-Fi antenna inside your phone.
So you have huge variety at the top and huge variety at the bottom.
In the middle of that hourglass, there's a narrow waist. One single unglamorous rule that everything above and below has to pass through. For the internet, that narrow waist is the Internet Protocol, or IP.
A developer building a weather app at the top does not need to know if you are using underwater fiber optics or a satellite link at the bottom. The IP layer handles the translation.
Because every app at the top and every cable at the bottom agrees to speak IP, anything built on top can reach anything else.
That single narrow waist is the only reason the internet functions as one cohesive global network instead of 1,000 incompatible private networks.
The conflict we are watching right now is that the 402 status code was supposed to be the single narrow waist for money. It was supposed to be one universal, boring moment where any AI agent could just pay for a service.
But now we have two competing waists trying to occupy the exact same slot in the hourglass.
This overlap is exactly why the biggest payment networks are betting on both. They know that a divided narrow waist creates massive fragmentation for developers.
If I'm building a brand new AI agent right now, this format war is my worst nightmare.
A universal layer only works if it actually stays singular. The entire value proposition of a narrow waist is that a builder only has to plug into it once to reach everybody else.
So if we have two candidate waists, a developer building an AI agent has a serious problem.
They either have to invest the time and money to make their software speak both languages, or they have to bet on one and risk losing access to half the open web.
It is the exact fragmentation that a shared protocol is supposed to prevent, showing up in the infrastructure of money itself. The open question is how this resolves for you, the listener, as you watch this space evolve.
Either one rail wins outright and the other one fades away, or developers are forced to choose sides forever.
Or a translator layer forms on top of them.
We have seen this specific historical parallel before with physical media. Video once had two fiercely competing tape formats, VHS and Betamax. The industry tore itself apart, forcing consumers to choose a side.
And then we moved to a handful of competing disc formats, HD-DVD versus Blu-ray, and the exact same territorial battle happened again.
But the format war eventually stopped mattering entirely because everything moved to streaming.
Streaming is a layer built entirely above the physical formats. The choice of the underlying format became invisible to the consumer. You do not care what kind of hard drive a video platform uses, you just hit play on your television.
If an agent can speak one universal language, and a translator layer quietly converts the transaction into whichever rail the receiving server prefers, the format war ends.
The underlying payment protocols become invisible plumbing. Wait, so Visa quietly supporting both by 402 and MPP is not just a financial hedge. Are they trying to build the streaming layer for money?
A bridge that translates between them so the developers never have to choose.
That bridge would solve the fragmentation problem immediately. It is not necessarily a bet that one side wins. It is the beginning of exactly the kind of bridging layer that a functional narrow waist was supposed to make unnecessary.
If that translator bridge becomes the real third protocol sitting above the first two, it changes the entire landscape of machine commerce. The companies that own the bridge will control the flow of machine money.
So if you're watching this space, you need to watch the scoreboard carefully over the next few months. You need to compare Buy402's raw payment volume against the number of raw service integrations that MPP is securing.
Whichever curve bends harder will tell us a lot about the momentum.
And it really is a race to see who becomes the default setting for AI commerce.
Connecting this back to the bigger picture raises a much larger issue for you to think about. If a third bridging layer emerges and makes the underlying rails completely invisible to the developers, what happens to the agents themselves?
That's a great question.
If we are building AI systems that can independently evaluate options, read complex cryptographic math, and execute intricate logic, will the next generation of AI agents simply learn to negotiate and invent their own momentary payment protocols on the fly, cutting the human networks out entirely? This is Plain Strata, decentralized AI layer by layer.